Hi, it's Jacob here with a physics tutorial today. So today's problem is we're gonna have one puck smash and collide with another puck, and they're gonna go off on separate angles, and we're gonna have to determine the final velocity of each puck after the collision. So we have our perfectly frictionless surface, of course, and Lucas here, and he will be launching the puck at exactly 5.4 meters per second into the other puck. So let's see how it goes. Thank you very much. Okay, so I'm at work at the pool now, but you still gotta do physics all the time. So as you saw in the previous video, it was obvious that puck B went off at an angle of 46 degrees and puck A went off at an angle of 33 degrees. Now, due to the law of conservation of momentum, which is the key to this equation, since there was no vertical movement in the y-axis with the original A puck's velocity, that means that the y velocities of the A and B pucks after are also going to equal 0. So from that we can say that the momentum of B in the y-axis is going to equal the momentum of A in the y-axis. And since our masses are equal, those cancel out, and we'll get two velocities equal to each other. Now from the diagram over here, we can see that we'll use the sine ratio for that. So we'll have VB sine 46 is equal to the velocity of A sine 33. And now we want to rearrange to isolate for one of our variables. We'll choose our B velocity in this case. So we'll divide by sine 46, and we will get an equation for our B velocity. Okay, so we're going to keep that equation in mind, and now we're going to want to solve for our x velocities. Now again, law of conservation of momentum is key. Since the initial total momentum of the system was 5.4 meters per second to the right, the momentum after is also going to have to be that. So since our A puck was the only puck moving at the start, the B is negligible because it's 0. So the momentum of A is going to equal the momentum of A after plus the momentum of B after. And if we realize again that masses cancel out, we're going to get our initial velocity, which was 5.4 meters per second, is equal to VA cosine ratio this time, since we want it in the x direction. So for A it's cos 33 plus, now remember we rearranged for VB over here, so we're going to substitute that equation into our equation we're doing right now, and we can't forget the cos there, cos 46. I already went ahead and did all the math for that, and we're going to get 5.4 equals 1.395 VA. So that gives our A velocity is going to be 3.975 meters per second.
Look at Jacob being all smart.
Okay, so the values we'll get, actually I made a mistake. 5.4 is going to be equal to 1.365 VA. So that'll give us a velocity of 3.957 meters per second. So we're almost done now. All we have to do is substitute our A velocity back into our B velocity equation. If we write out that, and we substitute in 3.957 meters per second, we're going to get our B velocity is around 3 meters per second. So in final, our B velocity is 3 meters per second. Our A velocity is about 4 meters per second. Thank you. That was physics with the lifeguards.
So fun.